Good day, learners. Today we are going to discuss linear and angular speed. But before anything else, do not forget to like, share, subscribe, and hit the notification bell so that you will be notified for my upcoming videos.
Uno, dos, tres, cuatro.
This video lesson will discuss about linear and angular speed. Let us define linear speed. Linear speed is a distance traveled by a moving object. The speed with which the object moves in a linear path is called linear speed. In simple words, we can understand that the linear speed is a distance covered by a body in each time travel. Angular speed. Angular speed is the measure of how fast the central angle of a rotating body changes with respect to time. Consider a particle moving at a constant speed along a circular arc radius r. If s is the length of the arc traveled in the time t, then the linear speed of a particle is linear speed is equal to arc length divided by time equals or s over t or equal to radius times the central angle divided by the time. Moreover, if theta is an angle in radian measure corresponding to the arc length s, then the angular speed, which is the lowercase Greek letter omega of a particle, is angular speed is equal to central angle divided by time or equal to the theta over the time. Example number 1. The second hand of a clock is 13.5 centimeters long. As shown in the figure at the left, find the linear speed of the tip of the second hand as it passes around the clock face. Solution. Take note that in one revolution, the arc length is equal to 2 pi r, and substitute the value of the radius, which is 13.5 centimeter, which refers to the length of the second hand of the clock from the center. Okay, so using the formula, the arc length s is equal to 2 pi r. Then what we are going to do is we are going to substitute now the value of the radius, which is 13.5 centimeter. So we come up with 2 pi times 13.5 centimeter. So as we are going to multiply now 2 times 13.5, that is equal to 27. So that is why the arc length is equal to 27 pi centimeter. Take note that the time required for the second hand to travel the distance is 1 minute or 60 seconds. Thus, the linear speed of the tip of the second hand is, so using the formula linear speed, which is the arc length over the time is equal to the s over the time. So all we need to do is we are going to substitute now the value of the s, which is the 27 pi centimeter divided by, since now that in the problem we are referring to the second hand, instead of 1 minute we are going to use now 60 seconds because the problem asks for what is now the linear speed of the tip of the second hand. So that is why the one full rotation of the second hand is equivalent to 60 seconds. So that is why the denominator or the time t is equal to 60 seconds. So as we are going to simplify now the fraction, that is equal to 9 pi over 20y, because the GCF between 27 and 60 is equal to 3. So 27 divided by 3, that is equal to 9, and 60 divided by 3, that is equal to 20. So that is why we have now 9 pi over 20 centimeter per second. And take note that the value of the pi If you are referring to the circumference of the circle, that is approximate 3.1416. So all we need to do is substitute on the value of the pi, which is 3.1416. So that is why we have 9 times 3.1416 divided by 20. So that is why we have 1.41 centimeter per second. So the linear speed of the tip of the second hand is equal to 1.41 centimeter per second. Example number 2. A Ferris wheel with a 65-foot long radius, as shown in the figure at the left, that makes 1.8 revolutions per minute. Find the angular speed of the Ferris wheel in radian per minute. Find the linear speed of the Ferris wheel. Okay, solution. How to compute the angular speed? So since the one revolution generates 2 pi, it follows that the turns of the Ferris wheel are 1.8 times 2 pi, which is equal to 3.6 pi radians per minute. In other words, the angular speed is the central angle over the time, which is the central angle or the theta, is equal to 3.6 pi radians, and then the time is 1 minute. Then we can say that the angular speed velocity is 3.6 pi radian per minute. Okay, letter B. How to compute the linear speed? Substitute now the value of the radius, which is 65 feet, and the theta, which is the angular speed, is equal to 3.6 pi radian per minute, to our formula S is equal to radius times the theta. And the time is equal to 1 minute. So using the formula, linear speed is equal to arc length divided by time. So our arc length is equal to S over time. Then we already knew that our S is equal to radius times the theta. So all we need to do is substitute the radius, which is 65 feet, and the theta, which is 3.6 pi radians. Then the time is equal to 1 minute. So as we are going to multiply now the numerator, 65 times 3.6, that is equal to 234. So the linear speed is equal to 234 pi feet per minute. So approximately, if we are going to substitute now the value of the pi, which is equal to 3.1416, and multiply it to 234, then we can come up with a linear speed of 735.13 feet per minute. Example number 3. The circular blade on a saw has a diameter of 8.5 inches and rotates 4,800 revolutions per minute. Find the angular speed of the circular blade in radian per minute. And letter B, find the linear speed of the circular blade on a saw. Okay, how to compute the angular speed? So take note that one full rotation or one revolution generates 2 pi. It follows that the turns of the circular blade on a saw are 4,800 times 2 pi, which is equivalent to 9,600 pi radians per minute. In other words, the angular speed is, so we are going to use the formula central angle divided by time, or the theta divided by t. So substituting now our angle, which is equal to 9,600 pi radians per minute, then we can say that the angular speed velocity is equal to 9,600 pi radian per minute. And Next, we are going to compute now the linear speed. How we are going to compute the linear speed? By substituting the value of the r, which is equal to 4.25 inches. Where did we get the 4.25 as our radius? And take note that in the problem, the given is diameter, which is 8.50 inches. Since now in the formula, we are going to use now the radius, so all we need to do is we are going to get now half of the 8.5, which is equal to 4.25 inches. And the theta, which is now the result in the angular velocity, which is equal to 9,600 pi radian per minute, must be substituted to our formula. S is equal to radius times theta, and the time t, which is equal to 1 minute, because in the problem the given there is the revolution per minute. So by substituting now, so our radius is equal to 4.25 inches times the theta is equal to 9,600 pi radians divided by 1 minute. So as we are going to multiply now 4.25 inches and 9,600 pi radians, that is equal to 40,800 pi radian inches per minute. So as we are going to simplify further, so the value of the pi is equal to 3.1416. It must be substituted to our pi. So it becomes 40,800 times 3.1416 inches per minute is equal to a linear speed of 128,177.28 inches per minute.
And that ends our video discussion at this moment. Thank you for watching. But before you will end this video, please do assess your learnings by answering the self-test activity. Thank you.